Good day, everyone. I'm Nicole C. Nebres, BSECE4. Today, I'll be presenting my project on designing a point-to-point path profile for microwave communication. This presentation will explain the entire design process from site identification and zoning verification to path profiling and signal analysis, ensuring that the communication link is technically feasible and compliant with engineering standards. The main objective of this project is to design a point-to-point microwave communication link by creating an accurate path profile. This involves analyzing the line of sight between two stations, calculating the required antenna heights, verifying terrain clearance, and ensuring that the path satisfies Fresnel zone requirements for reliable signal transmissions. So to carry out the design, I utilize several essential tools. First is the Microsoft Excel, used to perform computations such as earth curvature, line of sight, and Fresnel zone radius. Google Earth application, used to obtain geographic coordinates, elevation data, and to visualize the terrain. UISP Design Center, used to model and simulate the wireless link to validate its performance and feasibility. In establishing a microwave link, the critical initial steps are site surveying and path profiling. A site survey involves assessing potential installation sites to verify line of sight and detect any possible interference or obstructions. Path profiling generates a graphical representation of the signal path, accounting for terrain, elevation, buildings, trees, and the atmospheric refraction. This ensures that the microwave link maintains a clear and unobstructed signal path. For this project, I chose these two selected sites. The transmitter site is located at Tigbao Highland, Maligaw City, with an elevation of 424 meters. The receiver site is located at Zone 2, Mangawas, Albay, with an elevation of 27 meters. These 2 points form the basis of the design microwave communication link. Both the selected sites comply with the local zoning regulations for communication tower installations. The receiver site in Mangawas is in a semi-agricultural, low-density residential area, providing adequate open space and minimal interference. The transmitter site in Tigbao Highland, Ligaw City is elevated and sparsely developed, ideal for minimizing radio interference and maximizing transmission coverage. Both the locations meet municipal standards for tower construction, safety, and accessibility. The transmitter site is located at Tigbao Highland, Ligaw City. Its elevated terrain is advantageous for microwave transmission as it provides an unobstructed line of sight toward the receiving station, reducing path losses and improving signal reliability. The receiver site is located at Zone 2 Mangawas Albay, serves as the endpoint of the communication link. Its geographical position complements the transmitter's elevation, forming a direct and clear line of sight path necessary for efficient signal propagation. This is the elevation profile between the two sites. It illustrates the terrain and any natural or man-made obstructions along the signal path. By analyzing this profile, we can determine whether the line of sight is clear and if any adjustments to antenna height are necessary. For the path profiling process, I use Excel to calculate the following parameters. Earth bulge is the curvature effect of the Earth over distance. Line of sight is the direct visual path between antennas. Path clearance, ensuring the signal clears the range obstacles. Fresnel zones, particularly the first and second zones, which are critical for minimizing diffraction losses. These calculations ensure that the design link meets the minimum clearance requirements for reliable transmission. Path profiling table in Excel. This table presents the computed data for each segment of the path. It includes distance intervals, elevation readings, earth curvature corrections, and clearance computations. This result confirms that the path maintains sufficient clearance for signal propagation. Here are the list of formulas used to compute the technical parameters in Excel. Each formula was applied systematically to determine earth curvature effects, Fresnel zone radius, and the total clearance height, ensuring computational accuracy throughout the design. Path profile graph. The path profile graph visually represents the microwave link between the two sites. The curve indicates the terrain elevation, while the straight line represents the line of sight path. The visible clearance above the terrain and within the Fresnel zone confirms that the link is free from obstruction and suitable for microwave communication. To summarize, I successfully designed a point-to-point microwave communication link between Ligao and Nawas. By combining site survey, path profiling, Fresnel zone analysis, and software simulation, I achieved a reliable and compliant design. This project demonstrates how theoretical knowledge in microwave communication can be applied in real-world network planning and design.